For this session, we're going to review probability. We'll be using two previous free response questions to review. So this time, we're going to go over 2015 AP Statistics FRQ number 3. A shopping mall has 3 automatic teller machines, ATMs. Because the machines receive heavy use, they sometimes stop working and needed to be repaired. Let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected days. The table shows the probability of distribution of x. So if you look at the table that is given to us, we could tell right away that this is a discrete random variable. You have a finite number. You have 0 of number of ATMs working, 1, 2, and 3. And you have a probability that corresponds to it. Part A. What is the probability that at least one ATM is working when the mall opens? We said that x was equal to number of ATM that are working. So that was given to us. And our goal for part A is looking for probability that is greater than equal to 1. Get at least 1 means that it could be 1, it could be more, so it could be 1, 2, or 3. So this means probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Just keep in mind you could solve this problem as 1 minus probability of x equal to 0 since you have a finite number of ATMs. So probability of 1 was 0.21, 0.40 for x equal to 2, and x equal to 3 being 3 working ATMs at that moment was 24%. And if you add them up, you should have 85.85. So the probability that at least one ATM is working when the mall open is 85%. Part B. What is the expected value of the number of ATMs that are working when the mall opens? So the word expected value is another way to say mean or average. So part B is asking us to find the mean of the number of ATM. So we're looking for expected value of x. And to calculate the expected value of x is a summation of x of I times the probability of I, where I starts at 0 and ends at, in this case, 3. So first thing is, first random variable was 0. The corresponding probability is 0.15. Next random variable is 1. Probability is 21 that correspond to it. 2 is with 0.4. And 3 is with 0.24. And if you calculate this, you'll get 1.73 machines. Part C. What is the probability that all 3 ATMs are working when the mall opens, given that at least one ATM is working? So the fact that you have given, that's the condition part. So this is known as conditional probability. And our condition is that at least one of the ATM machines has to be working. So you're looking for probability of all 3 of them to be working. So x equal to 3, given that at least one of them is working. So this is equal to probability of x equal to 3 intersecting with x is greater than or equal to 1 over probability of x is greater than or equal to 1. And if you think about the probability of x equal to 3 intersecting with x is greater than 1, you could see that probability of x is greater than or equal to 1 is in blue color. Probability of x equal to 3 is in yellow. And the overlapping probability is just x equal to 3. And over probability of x is greater than or equal to 1. And the probability of x equal to 3 is 0.24. And the probability of x is greater than or equal to 1, again, we calculated this in part A, which came out to be 0.85. And the final answer is 0.282. Part D. Given that at least one ATM is working when the mall opens, would the expected value of a number of ATMs that are working be less than, equal to, or greater than the expected value from part B? Explain. Now, the given information has changed. They're saying that when the mall opens, there will be at least one ATM is working. So in other words, that probability of x equals 0 is not existing anymore. So if you calculate the expected value, if you compare them, and we know that probability has to add up to 1, so the chance of ATM working for x equal to 1 and x equal to 2 and x equal to 3 will naturally go up, which means the expected value will be greater than the one you calculated from part B. For next example, we're going to take a look at 2017, question number 3. A grocery store purchases melons from two distributors, J and K. Distributor J provides melon from organic farms. The distribution of a diameter of a melon from distributor J is approximately normal with mean of 133 millimeters and standard deviation of 5 millimeters. Part A. For melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137 millimeters? So the first thing I'm going to do is I'm going to try to define the values. I'm going to say x is equal to diameter of the melon from distributor J. Now looking back, we could say that the diameter of the melon from distributor J was normally approximated. So we could say that x is normally distributed with 133 as a mean and 5 as a standard deviation. So we're looking for 137 and greater. So this is the area that we're looking for. Our goal is to figure out x is greater than 137. So first thing we have to do is convert and find the z value that corresponds to 137 in that distribution. So z value will be 137 minus 133, which is our mean, over standard deviation, which is 5. This will produce 4/5, which is the same thing as 0.8. So now we know that we're looking for z is greater than 0.8 in terms of probability. Now looking at normal distribution table, we could figure out z-score that is less than 0.8 will come out to be 0.7881. So therefore, probability of z is greater than 0.8 will be 1 minus the probability of z is less than 0.8, which means the answer comes out to be 0.2119 as the answer. So continuing with the information that is provided, it says distributor K provides a melon from non-organic farm. The probability is 0.8413 that the melon selected at random from distributor K will have a diameter greater than 137. For all melons at the grocery store, 70% of the melon are provided by distributor J and 30% are provided by distributor K. Now here's a question. Part B. 4 melons selected at random from the grocery store. What is the probability that the melon will have a diameter greater than 137 millimeter? Once again, let's start with notating some of the variable. I'm going to say J is melon from distributor J. K is the melon from distributor K. And I'm going to say G for melon diameter that is greater than 137 millimeter. Don't forget this variables are different from part A. Part A we defined it as melon's diameter that is greater than 137 just from distributor J. For letter G in this case, we're referring to all of the melon, so there are two different values. There's a couple ways to approach this. We could try to draw it out either using tree diagram or two-way tables, or try to solve it using mathematical notations. I think it's always easier to look at it as a diagram, so I'm going to go with tree diagram in this case. So let's start with the distributors. We know that there are two distributors, which is known as J and K. And J, they said about 70% of the melon is coming from there, and the remaining 30% is coming from distributor K. Now from part A, we were able to figure out that the melon's diameter greater than 137 was 0.2119. So that means that is not greater than 137, has to be the complement of that, which comes out to be 0.7881. For distributor K, it was given to us. They said diameter greater than 137 was 0.8413. Once again, making a complement of 0.1587. Now, let's look at the chart. So what does this mean? It means that a melon's diameter greater than 137 that came from J was 0.2119. So how many of those came from J and the diameter will be 0.7 times 0.2119, which comes out to be 1483. Again, only thing we care about is what are the melons that is greater than 137 as a diameter, so which is G. So from distributor K will be 0.3 times 1 0.8413, which comes out to be 2524. And if you add them up, you will get the answer of 0.4007. So we could figure out the probability of G is equal to 0.4007. Part C. Given that a melon selected at a random from grocery store has a diameter greater than 137 millimeter, what is the probability that the melon will be from distributor J? So for part C is the conditional probability. They said they want the condition being that it has to come from grocery store that is greater than 137. So our condition is G has to be greater than 137 of the diameter. And we want to find the probability that the melon came from distributor J. So this will be probability of J intersecting G over divided by probability of G. Now if you look back, we calculated already the probability of it came from distributor and being greater than 137 a diameter, which was 0.1483. And from part B, we calculate the probability that is greater than 137 of diameter for all melon, which was 0.4007. So our answer comes out to be 0.3701 if you divide them. If there's any question, feel free to leave a comment below. If you found this video to be helpful, like the video or subscribe to the channel.